Scientists, I hope you are ready to go and have your notebooks out in front of you. Today, class is going to be over video because I'm obviously not here, and so instead I've made you a video version of me so that we can still keep learning and moving forward about the sun. So please take a moment to pause the video right now and try out these warm-up questions. You're trying some comparisons and thinking about the sun. Please pause now. Awesome. So I hope that you took some time to write some sentences practicing using comparing words like conversely or compared to. For example, in middle school, our classes were short. Conversely, in high school, our classes are much longer. So I hope that you practiced that and you tried using this sentence frame to describe these two different molecules, both made of the element oxygen. So we have done our warm up. And today we're going to do a couple of things, but actually my agenda is a little bit wrong here. So let me just clue you into one more thing. We're actually not going to check out a simulation. That'll be next class when I'm back. But we're going to be doing a little quick quiz at the end of the hour. We're going to be talking about what does the sun actually do, looking at some data, finding some evidence, and making some claims from that data. So that's our plan for today. Let's jump on in. So last class, we really solidified that our knowledge from the sun spectrum is that the sun has hydrogen and helium inside it, and sodium too, but not everybody talked about that, but it does. And the thing is, that's cool and all, but like, how does the sun actually make all this energy that comes to Earth? We know it's a lot of energy that comes to Earth. We know the sun makes even more energy than that every single second. And so we want to figure out, how does it make that energy? And so today's question is, how does the sun make so much energy? Which I'd like you to write on page 23. If you need to pause the video here, you could. But hopefully you've written this question, how does the sun make so much energy? Because that's going to be our whole goal today. And the things that people often say about the sun is that it's on fire, it's burning, it has lots of explosions or burning happening on it. Or sometimes people talk about another thing that we'll talk about. But the first thing I want to mention is this burning idea. Burning is something that you are familiar with. You've seen stuff burn. And burning is when we combust. The scientific word for burning is called combustion. And hydrogen here is getting burned with oxygen. And so I need both hydrogen and oxygen together. Then they combust, they burn, and they make water, H2O. Isn't that kind of weird? The stuff that we start with over here is called a reactant. It's the starting stuff. And then they make the products, they're things they produce. You'll notice that it also makes a lot of energy. So you're familiar with this because if you light a match, that's burning that match. The match has hydrogen and carbon actually in it, but here's the most basic combustion equation. And that releases energy. You feel that energy as heat energy. And you're pretty familiar with this. So here is the burning of hydrogen. Ooh, big flames. Very exciting. Let's one more time. Yeah, very fun. So this is called combustion. Make sure you've tried saying this word, combustion. Your turn. Combustion. Right on. So then sometimes people don't say that the sun is burning stuff. Instead, they say that the sun is fusing or going through this thing called nuclear fusion, which I've heard a few of you say before. Nuclear fusion also has reactants. And in this case, the nuclear fusion reactants are two hydrogen atoms. And they get smushed together in fusion to become a new element, which is pretty wild. They become the element helium and release some energy. So that's our products, a new atom we didn't have before, we do have after, and energy. And so this is called nuclear fusion. And you've maybe heard of that as well. So today we're going to be digging into what is actually happening here. Right now, we're going to make sure that we hand out this paper if you don't already have it. You're going to be folding it in half, so it looks like a little booklet like this. We will put it in our notebooks here on page 23, right below our focus question for today. But I wouldn't put it in just yet, because it's kind of annoying to have it stuck in your notebook while you're writing inside it. So that is where we're going to put this at the end of class today. I would like you to read this part aloud together as a class. I'm going to ask the person who's sitting closest to the door to actually read the very beginning. It says, elaborate, our sun. And you can stop whenever you want to, person closest to the door. This number here I know is hard to read, so I've put in a little, how you say it. It's 4.2.41 times 10 to the 39th. But person closest to the door, you're going to begin reading. Then when you're tired of reading, you're going to popcorn to another human being, and they will read. And then when they're tired, they'll popcorn to another human being, and so on until we've read this whole thing. Please pause the video now so you can read aloud. Wonderful. So you have done some reading here about the things we already know about the sun. All of this is stuff we already know. Then I have this data for you about these two types of reactions. These are the two reactions that we think could be happening inside of the sun. And you can see the equation here written in letters and shown in pictures. And I have some additional data here about them that you can see. The energy released by one reaction and how long before the fuel, the reactants, this stuff, this side, would run out if it were burning up inside the sun to make the right amount of energy. So I'm going to ask you to, again, pause the video right now and take a moment to write down what you see in each side of each of these reactions. Awesome. So we are going to jump in and try to actually look at this evidence and use the evidence to make our decision. But I want to know right now, what are you thinking? What's your kind of gut? In science, we call our gut, our instinct of like what we think will happen, our hypothesis. It's our initial idea. So you're going to take a moment and circle right here. Do you think the sun is burning in a chemical reaction to make all the energy? It's a lot of energy. Or is the sun doing this thing called a nuclear reaction to make all that energy? So take a moment and just circle whichever one you think. No big deal. Aces. So then we are going to jump in to actually look at the evidence here, because in science, we need evidence to really make a decision. And so we're going to jump in with our first evidence, which is looking at the composition. We're going to look at the composition of these two reactions and what we know about the composition of the sun. And so right here, we're going to start off by saying, okay, based on those two reactions that I just looked at, here they are. The things that are required in a chemical reaction are the elements or molecules that are present in that reaction. And so I can look and say, oh, well, the reactants are hydrogen and oxygen, and then they make H2O. Their product is H2O or water. So if that reaction were happening, I would see hydrogen, oxygen, and water inside the sun. Take a moment and decide, does this evidence support a chemical reaction? Maybe, maybe not. Maybe not enough info. You decide. Then we can go over and look at that nuclear reaction. If you flip back to the front of the page, you can see, oh, hey, the nuclear reaction, the things you need, the reactants that react together are hydrogen. So just hydrogen. And they make the element helium. So the product is helium. So those are the two things that would be present if this type of reaction were happening. And again, does this evidence support a nuclear reaction happening inside the sun? You decide. Check one, yes, no, or not enough. Because we actually know what the sun is made of. You just identified this last class and for the last, 2 weeks previously, that based on the sun spectrum, y'all decided the sun has hydrogen and helium inside it. It also has sodium. It also has some other things, but again, mostly hydrogen and helium. So that can help you decide, based on this absorption evidence we have from of the sun, showing that the sun is composed of hydrogen and helium. This supports either a chemical reaction or a nuclear reaction because. So this is your turn to think about the reasoning. Please pause the video now so that everybody can write down their reasoning. Awesome. So then let's dive forward into the energy amounts. And this one is maybe the most challenging section because it's looking at really big or really small numbers. So we learned that the sun releases a whole lot of energy every single second. 2.41 times 10 to the 39th mega electron volts. That's a lot. It's enough energy to power the entire world for 100 years. And the sun is doing that every single second. Dang. Sun, you got a lot of energy. Then the data that I've given you here about chemical reactions is how much energy is released by one chemical reaction. When you have 2 hydrogen molecules and 1 oxygen molecule, this is how much energy they can release through combustion. Then for our nuclear reaction, if I have 1 hydrogen atom and 1 hydrogen atom, they fuse together to make a helium atom. That's the amount of energy they release. So we've got these energy amounts, and we can go ahead and fill in the information that we know here. I've got this number already written down here for you about the sun because it's a big number. But I'm going to let you fill in the amount of energy released or made by this chemical reaction. And take a moment to decide, does that evidence support a chemical reaction happening? You might have to do a little bit of comparison with the amount that's released for every nuclear reaction. You decide. And then we're going to fill in our reasoning. So we're going to say a chemical reaction produces either a large or small amount of energy. A nuclear reaction produces either a large or small amount of energy. And does that support the chemical reaction more or the nuclear reaction? And you're going to take a moment to pause here so everyone can write down their reasoning and think through which one. That one was tricky. Let's move on to something that I think you'll find a little bit more straightforward. So we're going to dive into the age of the solar system. We looked at a timeline a while ago. You remember this timeline? So we looked at this timeline a long time ago, and we saw that the solar system was created, the formation of the sun and all the planets in our solar system, 4,600 million years ago. It's a pretty long time ago. And so we can actually add that piece of information in here as something we know about the sun. We know that it was created back when the solar system started a long time ago. So I'm going to add that in right here. Hey, there we go. 4,600 million years ago. Or you could write this as 4.6 billion years. Either one, A+. So that's what we know about the sun. Then you're going to need to take a moment to look at, hey, this data you have on the front of your packet to write down how long would this fuel of a chemical reaction last for the sun to give that right amount of energy. How many years? And then what about the nuclear reaction? Take a moment and think about, do you think either piece of evidence supports being the thing that is making energy inside the sun? And just like before, we're going to go ahead and write down our reasoning. And we're going to write that this supports either a chemical reaction or a nuclear reaction. Because, ... You tell me. Oh yeah, pause now so you can write. Awesome. So finally, we need to make a decision. And you are in charge of this decision. So I'd like you to decide what your final claim is. Is the sun's energy produced by a chemical reaction or by a nuclear reaction? And I'm going to invite you to write your claim down. I claim the sun produces energy through chemical reactions happening inside the sun or through nuclear reactions happening inside the sun. And you're going to tell me about what piece of evidence is most convincing to you. The evidence that best supports this claim is and then give me a little bit of why, because. And then what other piece of evidence, because you don't want to have just one piece of evidence that supports this, you should probably have two, maybe even three. And you'll describe that right here. And we're going to go ahead and pause the video so that you can write down your final claim with evidence and reasoning. Awesome, scientists. So now is the moment to really get yourself nicely organized. If you don't have tape or glue, make sure that you grab some from the supply box. Send someone from your table over to pick up a supply box and tape or glue this right here onto page 23. You don't need very much glue. You don't need very much tape. Be conservative. So we have lots all year. And then we are going to actually submit this onto Schoology. It's 2.1, and you're going to take a picture of the inside right here and submit that to Schoology. Awesome. If you need to pause the video here, you can. Actually, this is the last piece of directions because I have a little check-in quiz for you that goes over pretty much everything we've talked about this year, and you should use your notebook to help you with it if and when you get stuck. So, good luck, scientists. Great work so far. Please make sure to take your picture 2.1 and try this quiz 2.2 and put your assignment in your notebook so you don't lose it, because you'd be really sad if you lost it. And I hope you have a very lovely weekend. Bye, guys.